Hi everyone and welcome to Island Technology's presentation on DrayTek Wi-Fi solutions. This is part 2 of our 3-part series of webinars on this topic. My name's Darren and I'm the Queensland Sales Rep at Island Technology. In part 1 of this series we had a brief look at the history of Wi-Fi and how it's being used. We also looked at wireless standards, wireless technology components and some antenna theory. In this webinar, we'll be taking a look at the menu options in DrayTek routers, which we hope will provide a better understanding of what these features are and what they can be used for, and we'll also be looking at Wi-Fi mesh networks in DrayTek products. Okay, so let's take a look at the DrayTek router wireless menu. Shown here are the Wi-Fi options for both the 2.4 GHz and 5 GHz bands as they appear in the main menu in the dual band VIGA 2926 AC model. Single band models will only have the 2.4 GHz band, and some like the tri-band VIGA AP1000C have 3 bands to configure, which are 1 by 2.4 GHz and 2 by 5 GHz bands. The menu options available for each Wi-Fi band are very similar between models. Let's have a brief look at them, starting off with general setup. We get similar options for both the 2.4 GHz band and for the 5 GHz band, with just the mode and channel selections being different. 4 SSIDs can be configured. Options for each SSID include hide SSID, isolate member and isolate VPN. These tables show the available channels for the 2.4 GHz and 5 GHz Wi-Fi bands. If left on auto select, the router or AP will choose the optimum channel for you. Beware of DFS, also known as dynamic frequency selection in the 5 GHz range. The bands from channel 52 to 140 are also allocated to military radar, satellite communication and weather radar. In some DrayTek models these channels won't be available at all, but in the models that do support DFS, selecting one of these channels or the auto select option will cause the warning above to pop up. A requirement for Wi-Fi products to use these bands is they first have to scan and detect that it's not already in use by one of these services, and then rescan every 24 hours. During the scanning period, the Wi-Fi service will not be available. Moving on to security settings, this menu option allows the configuration of security settings for each SSID 1, 2, 3 and 4. You can select the security mode and WPA settings. For added security, each wireless router is now supplied with a pre-configured password, PSK. The unique Wi-Fi password for each router is printed on a label on the base of the router. There's lots of options for the pre-shared key, also known as the Wi-Fi password. The easiest to use and the most secure one for home users is WPA2 PSK, but there's other options there if you have devices that don't support WPA2. There's also 802.1x authentication options, which will require an authentication server known as a Radius server. Radius is an acronym for Remote Authentication Dial-In User Service. Access control. Access control is used to restrict wireless access for certain wireless clients based on their MAC addresses, which can be entered into a black or white list. The black list will block Wi-Fi clients with a matching MAC address, while those in the white list will be permitted to connect. This can be configured for each SSID. WPS Wi-Fi protected setup provides an easy method to make network connections between wireless stations and an access point or a VIGA router using WPA and WPA2 encryption. With this method, there's no need to select any encryption mode and enter a long encryption passphrase to set up a Wi-Fi connection every time. Instead, just press a button on the wireless client and WPS will establish the connection between the wireless client and router automatically. To turn on WPS, method 1, just press and hold the wireless LAN on-off WPS button on the front of the panel, or if the router isn't easy to get to, you can log into it and go to Wireless LAN WPS and click Start PBC. The activity and WLAN LEDs will flash rapidly for 2 minutes waiting for connections. During that 2 minutes on the wireless client, simply select the router's SSID and click on Connect and job done. WDS. WDS Wireless Distribution System is a protocol used to wirelessly connect access points, APs, or wireless routers. It can be used to wirelessly bridge two LANs or extend the coverage of a wireless LAN. 2 modes are available. The first is bridge mode, which means packets received from a WDS link will only be forwarded to local wired or wireless hosts. The second is repeater mode. The packets received from one peer AP can be repeated to another peer AP through WDS links. Repeater mode can do WDS to WDS packet forwarding. In other words, the host on the far left in the diagram above can communicate with the one on the far right via the center host, as long as the center one is set to repeater mode. However, if all three hosts are in bridge mode, then the devices will only be able to communicate to the next host in the line. Hosts 1 and 3 can't communicate in this case. Only repeater mode will allow WDS to WDS packet forwarding. Advanced settings. In the Advanced Settings menu, we can change parameters such as operation mode. Greenfield operation mode provides the highest throughput, but only works between 11N systems. It doesn't have any protection mechanism to avoid the conflicts with neighbouring 802.11a, b or g devices. Channel bandwidth we discussed in our first webinar. Generally, the 20/40/80 option is the way to go, but some older Apple devices will only work with channel bandwidth set to 20 MHz, for example, so you have the option to change it to that here. Guard interval refers to the spacing between characters being transmitted. A shorter guard interval means a faster data rate, but can result in a higher packet error rate. Leaving it on auto is the safest bet. Aggregation MSDU. MSDU stands for Max Service Data Unit. MAC, of course, stands for Media Access Control. This is basically about combining multiple Ethernet frames into one 802.11n frame, which improves the efficiency of wireless data transmission. TX power refers to the transmission power. More isn't necessarily always better, and you can reduce it if it's interfering with some other wireless device, or if you'd like to reduce the chances of neighbours finding it and hacking your Wi-Fi, for example, or if you just want to be a good neighbour and not drown out everyone else's Wi-Fi. A good rule of thumb is to start low and only increase it to the point where you have the coverage you need. WMM capable refers to Wi-Fi multimedia, which works a bit like QoS, giving audio, video and voice priority. APSD stands for Automatic Power Save Delivery. RTS, Request to Send, basically asks wireless clients for permission to send the next data packet. Generally, leaving it on the maximum value of 2,347 bytes is the way to go, but if you're having trouble with dropouts and the need to reboot the AP or router to get things moving again, you can try setting a lower value here. Station control. Station control is used to specify the duration of the connection time and reconnection time for wireless clients. This feature is useful when a business such as a coffee shop provides free Wi-Fi for their customers. It prevents Wi-Fi users from hogging the network. In the example shown here, we've limited the Wi-Fi connection time to 1 hour for each user, and they're also limited to 1 session each day. So once their hour is used up, they'll have to come back tomorrow to get back onto the free Wi-Fi. Bandwidth management. Bandwidth management allows a limit to be set for Wi-Fi traffic to prevent some applications like FTP, HTTP, or some peer-to-peer from consuming all of the available bandwidth. AP discovery. This function is used for a Vigor router or access point to scan available Wi-Fi channels and produce a list of nearby access points. This information can be used to select a suitable Wi-Fi channel to give the best connection. Clicking on Statistics will display the number of access points per channel, along with the recommended Wi-Fi channel to use. This feature can also be used when troubleshooting Wi-Fi connectivity to check if the router can detect other Wi-Fi devices. A handy little Android app that can also work out the optimum Wi-Fi channels to use is called Wi-Fi Analyzer. This will show all of the wireless devices within range in the area, along with their signal strength in a neat graphical format. It does both 2.4 and 5 GHz bands. Pictured here, we can see a few of my neighbours using channel 1 and there's another one on channel 10. So I've put one of my APs in green there on channel 6 and the other in red on channel 13. The app has ads but is free from Google Play. Airtime fairness. Airtime fairness can be used in a mixed environment where slow Wi-Fi devices can significantly impact the performance of faster Wi-Fi devices. Airtime fairness is triggered when the configured triggering client number is reached. Band steering is only found on dual and tri-band models. Band steering encourages dual-band capable wireless clients to connect to the faster 5 GHz Wi-Fi and leave the 2.4 GHz Wi-Fi less crowded for those clients that only support 2.4 GHz, thereby improving the Wi-Fi performance for all Wi-Fi clients. This option is only available in the 2.4 GHz Wi-Fi menu in dual or tri-band models. We showed a video explaining airtime fairness and band steering in a little more detail in part 1 of this webinar series. If you'd like to watch it again, I'll include a link in the description below. Roaming. Roaming allows wireless clients or stations to reconnect to another access points with a higher signal strength when moving within an area serviced by multiple access points. Each access point must have roaming enabled. The menu option looks a bit different in the Vigor AP903. Station list. Station list displays information of connected devices. The information includes IP address, MAC address, and associated with. The status will show us whether it's connected or not and what sort of encryption is being used. In the Advanced tab, we get more details such as AID, RSSI, rate, BW, PSM, WMM, PHMD, and MCS. In the Neighbour tab, we can see vendor information, approximate distance, SSID, and visit time. Here we have the station list for access points. This is the Vigor AP903 shown here. It includes a graphical display showing the number of Wi-Fi clients over a 24-hour period. Just a quick look at a couple of other differences in the menu options available in access points. One of the differences you might notice in DrayTek Vigor access points compared to routers is that they have a choice of operation modes that can be selected. Later model access points have different selections and include the Wi-Fi mesh options. Speaking of mesh, let's now have a look at configuring Wi-Fi mesh networks. One method is to use the web interface in the Vigor access point or router. Using the wizard will guide you through the process. Start by selecting the operation mode and set up the Wi-Fi details and password. After clicking finish, just power on the other APs that you want to add to the mesh. Those subsequent APs will be the mesh nodes. The mesh root AP will search for available APs nearby. Next, select the access point you want to add as mesh nodes to the Wi-Fi network. Note that the access points must be in their factory default settings to allow auto discovery and configuration. Alternatively, DrayTek has a wireless app for both Android and Apple iOS devices, which can also be used to set up a mesh network. When a group of APs is working as a mesh network, you only need to configure the mesh route, which is the AP connecting to the internet gateway by Ethernet cable, and other APs in the mesh group, the mesh nodes, will connect to the mesh route wirelessly and sync the configuration with it. The apps can be downloaded from the App Store for Apple devices or from Google Play for Android. Once the app is installed on your device, select an access point as the mesh route and use the Quick Start wizard to set up the mesh network. Okay, let's check out a video showing how to configure the Wi-Fi mesh by using the Quick Start wizard in the Vigor AP903 access point and also by using the wireless apps for Android and Apple devices.
Hello everyone, my name is Ashutosh Sabharwal. In this video, I'm going to show you how to set up a wireless mesh network using two DrayTek Vigor AP903. Before this, let's first try to understand what is Wi-Fi mesh technology. Wi-Fi mesh technology is a plug-and-play technology used to easily configure a Wi-Fi mesh network. It simplifies wireless bridging of wireless access points to provide extended coverage in a network. The mesh route is first configured, then up to 7 mesh nodes can be added to form a Wi-Fi mesh network as shown in the diagram. Meshing provides the optimal path to an access point, adding redundancy and reliability. The self-healing feature of the mesh technology ensures an alternative path will be built in the event of uplink failure, ensuring continuity of Wi-Fi services. Currently, Wi-Fi mesh technology is supported only in these devices, but more devices will be added in future. Let's first start by looking at how to configure a mesh root device. Before configuring a root or a node device in a mesh network, make sure all the devices are restored to factory default settings. There are 3 ways to configure a mesh network. One is through Quick Start wizard. Another is to manually configure through DrayTek user interface, and the third is through DrayTek wireless app. Let's configure it through Quick Start wizard. Connect your AP903 with a laptop or a desktop, and then open the browser and log in to the access point using its default IP, that is 192.168.1.2, and admin as username and password. Click on Quick Start wizard and select the operation mode as mesh root. Give a name to the group and click Next Step. Enter the Wi-Fi SSID name and password. If you wish to enable second Wi-Fi, you can do this by enabling this checkbox. This Wi-Fi setting will apply to all the node devices in the network. If you like to change the default admin username and password, this can be done from here. But keep in mind that this will also apply to all the nodes in the network. Before you hit finish, go through the configuration settings. After hitting finish, the access point will provision itself and will start to look for nearby access points to add them as a node in a mesh network. Select all the access points which you like to be a part of mesh network. Give them a name and hit apply. This shows root device has successfully provisioned the node device. To check for the recently added mesh node device, click on mesh and then on mesh status. The device with hop count 1 is the recently added device. The green indication means the device is ready. The yellow indication means the device is being provisioned. And red indication means the root device is not able to communicate with the node device. Let's now look at how to manually set up a mesh network through DrayTek web user interface. Log in to the access point and go to operation mode. Select mesh root and click OK. It might take few seconds to set up a device as mesh root device. To see if a device is set up as a root device, we need to select mesh status under mesh. Check for the link status, which should show connected. To configure a node device, go to mesh setup and click on search under add mesh node. This search will list down all the available access points. Select all the access points which you would like to be a part of mesh network. Give them a name and hit apply. It might take few minutes to provision the node device. This shows the node device has been added. To verify the node device is synced with root device, go to mesh status. If you have multiple access points configured, you can isolate them with the device name or the MAC ID. If you wish to change the Wi-Fi SSID username and password, you have to make the changes in the root device. Once done, you have to go to configuration sync under mesh and check all the options for which you like to distribute. Like in this case, we changed the SSID for wireless LAN 2.4 and 5 GHz band. When you hit apply, the modified parameters would be synced to all the nodes in the network. The new Wi-Fi SSID should reflect on all the node devices. Let's discuss the last option to configure the wireless mesh using DrayTek wireless app, and it can be downloaded from Android and iPhone App Store. The first step is to connect to the Wi-Fi of the root device, and for that we need to click on Quick Start Wizard and enter the SSID and password to join the network. Once you are connected, select the operation mode as mesh root, give a name to a group and hit next. If you like to change the Wi-Fi SSID, this can be done from this option. Important thing to remember here is that the same SSID would be synced with all the devices in the mesh network. You also have an option to enable the second Wi-Fi, which can be done from here. This option allows you to change the login credentials. Remember, these credentials will be synced with all the devices in the network. Check for all the settings and hit finish. Join the new Wi-Fi network as we changed the Wi-Fi SSID. Once you are joined, The application will search for all the node devices in the network, so make sure all the access points are powered on. It might take a minute to search all the APs and will populate all the searched devices. Select all the APs which you would like to be part of mesh network. Give them a name and hit next. Once you hit apply, all the parameters will be synced with all the selected node devices. This shows the added node device and you need to hit finish to end the setup. If you wish to check for the added device, click on devices option and it will show you all the node devices with their hop count. If you wish to get the information of internet speed, use the speed test application as shown in the video.
Okay, the latest firmware version 3.9.2 for the VIGA 2862 AC or VAC and 3.93 for the VIGA 2926 AC or VAC wireless routers include the Wi-Fi mesh feature, which also supports access points connected to the router by cables. This is known as mesh wired uplink. When using a Wi-Fi router as a mesh route, VIGA AP mesh nodes can be connected to it via cables or Wi-Fi. Another situation you might want to use mesh wired uplink is when your VIGA APs are powered by PoE from a switch and you want a mesh network. Because they're attached by cables which provide both power and data to the APs, a loop between the wireless and wired connections for each AP occurs. Enabling the wired uplink option will prevent this loop. To set up a mesh wired uplink, firstly log into the APs and go to the mesh setup section. The wired uplink checkbox will appear when mesh node is selected. Then on the router, it's simply a matter of enabling the router as the mesh route using either the mesh setup menu or the mesh wizard and then adding the mesh nodes. Another option if you need an AP to be the wireless route and the router's Wi-Fi broadcast to remain out of the mesh group, you can set it up per this diagram. Okay, so in summary, today we discussed Wi-Fi in DrayTek routers, which was the second part of our three-part series, and today's presentation covered the DrayTek wireless menus in both routers and VIGA APs, configuring Wi-Fi mesh networks, and when and how to use the mesh wired uplink feature. For more information about DrayTek products, please check out our website at www.draytek.com.au or send us an email to sales@draytek.com.au or maybe give us a call on 02 9838 8899. Don't forget to like and subscribe below, and if you'd like a notification of new premiere videos we're about to launch or anytime we put up a new video, please give the bell a click too. Thanks and bye for now.